Welcome to the Teachers to Tech podcast. I'm your host, Dean. This is the podcast where we tell you how you can grow your tech skills, whether you're starting from scratch or just want to go farther. You might be thinking about a new job, a whole new career, or just a new hobby. We'll have something for everyone, so keep listening. Welcome to our 12th episode. This will be the final episode in the first season. We appreciate those of you who have followed us through the first season and those of you who have found us just recently. We do probably have some format changes coming up in the next season, thinking of producing fewer episodes but spending more time on each topic. And we have some good topics lined up for next season. But if there's a topic you'd like to hear covered, please be sure and use our feedback form. Let's dive right into today's topic, which is, should you learn to program? Notice I don't say, can you, because you can. Starting out in programming isn't really any harder than learning some of the more complicated board games that are on the market right now. Is programming for you, though? That's probably what you're wondering about. Let's separate the legitimate knowledge of programming from imaginary obstacles. I'm not trying to make a case that everyone needs to become a programmer, but I do want to make sure that your decision to learn or not to learn some computer programming is based on accurate information. You might think that learning programming is going to take up a lot of time or it's going to take specialized software, but I'm going to steer you toward methods of learning that are built in small segments and run on most home computers. Even a basic understanding of a programming language will bear a lot of fruit. Along the way, you're learning a lot about operations your computer carries out, and you might even be able to start to separate some of the truth from fiction when you're dealing with people who are trying to sell you services related to tech. Learning even one programming language will help you develop an appreciation for the types of learning that are related to programming. This is helpful for those teachers that are involved in curriculum decisions, but it's also helpful for those who are going to change jobs and are trying to get a feel for what a technical environment would be like. While you may not be learning exactly the tech you'll be working with, you have a good idea of what types of things you will run into. You'll also gain a sense of mastery over computers, and that's going to spread into other areas of computer work. So you might find yourself much more willing to troubleshoot your own computer issues because you know that you've programmed successfully before. You may even find yourself branching into other areas. For example, a teacher who learns some Python because it's easy to learn and popular might get the confidence necessary to also learn how to build some time-saving macros in Excel. And that's the kind of project that gets attention in the workplace, and it looks good on a resume. When I was researching for this episode, I went to one site from a big company that offers a little bit of lesson and, hey, here's our programming language and how to use it. And you know what? You almost had to already be a programmer to understand the site. I didn't like that at all. So I've thought about what does it take to get us oriented so we get to a programming language and know what to expect. And that's what I've got for you now. So my section here is about what should you know about programming languages to start out. So here we go. At its heart, your computer is operating with a single language called machine code. This is understandable by your processor, but it's not very intuitive for humans to work with. So various other languages were created that can be written by a programmer, then translated into a file that computers can run. This translation is frequently done by specialized software called compilers. This makes it easier for the programmer to write complex programs after learning the basics of a programming language. If you've seen or heard the names of programming languages, you might wonder why there are so many. The answer in one word is specialization. Imagine that you and your roommate have a single word that you use, like wash, that signals, hey, it's your turn to do the dishes. This single word would be like a command in a higher level programming language, and the instruction to clean the dishes would be analogous to the machine code instructions churned out by the compiler in response. The key or reserved words in a language and their corresponding machine language instructions are determined by those who create the language. So they can say this keyword tells the computer to do whatever they want it to tell the computer to do. For instance, one language, SAS, can analyze a data set and return a series of statistics in response to one single command. Visual Basic for Applications makes it easy for programmers to add buttons, message boxes, and other user interface elements into their programs. And these differences that I'm talking about are usually the determining factors when an enterprise is choosing which programming languages to use. I said languages in the plural because in most work where the programs are the focus, it's unlikely that a single language is going to do everything that's needed. The programmer's job is simply to learn the rules of whatever language they're involved with and apply those as they build a program. When we come back in a minute, we'll talk a little bit about how programming languages do their work. I've already described the way programs can give our computers instructions, but what are those instructions? Two types of tasks we often assign to computers are manipulating characters, meaning letters and symbols, and math operation. We might type a student's name into a search box and have the student's contact information come up on our computer screen. Or we might type in the price of some merchandise and have the computer calculate the sales tax on that merchandise. These are really simple operations and it wouldn't take long programs to accomplish either of those. But I do want you to notice that each of these programs accepts input from the user and provides output as well, which are two other basic functions we can expect of most computer programming languages. For more complex operations, the program might need to repeat or to make decisions. Programs can often contain sequences called loops. These are portions that repeat until some goal is reached. A program might run through every line in a data file, checking on every line for a certain value. At some point, the program might find the value it's looking for, and then it could return to the user the line number that contains that value. How does the computer know what line it's on? Through the use of something called variables. Variables are placeholders in a program that can be assigned to remember values, such as numeric values like our row number, or string characters like a student's name. We can put a variable in our loop, adding 1 to its value every time we look at a new row. That's how we can track our row number. But how do we stop? We can use a statement based on a condition. This is often an instruction with the keyword if in it. The program could include an instruction with a condition that tells the computer to tell the user the line number if it has found the value we're looking for, and to stop running the loop. Since this is an audio format, I'm pretty sure you've had about all the overview you can absorb just listening. I'm going to put a transcript of this episode up on the website for anybody who'd like to review it and take it over and over again or pick out the key points. But by now, you should be a little bit oriented to the world of programming. You may have even realized that learning to program is definitely something you can do. Let's talk about which language might be right for you when we come back. Let's talk about what's out there in the world of programming languages and how they can be used and learned. First off, one language that I hear mentioned every so often when I ask people about their technical background is HTML. And they'll say that they have programmed computers with HTML. But you should know HTML is not strictly a programming language. Most of its job is to decide the content and look of a web page. And you may not get the full programming experience if you choose to start with HTML. If you're interested in web design, or that's just where you want to start is HTML, then I'm going to refer you back to an earlier episode we did called The World's Smallest Web Page, and that'll help you get started. Next on my list is Visual Basic for Applications, or VBA. It's a programming language that's built into several Microsoft applications. It enables you to turn a simple spreadsheet, for instance, into an application that you've designed. You might use it to enable a user to select data from a spreadsheet, then create a report in Microsoft Word, all at the touch of a button. One use I have for VBA is to put student data into a spreadsheet along with class information. The program then opens Microsoft Word and creates a certificate for each student finishing the class. It converts them to PDFs, and it emails the certificates to the individual students. While Microsoft does have some advice on learning VBA, it's mostly general. My suggestion here would be for you to go out to Coursera or Udemy and look for some good courses on VBA. Next up is JavaScript. This is a language that's often used to add functionality to websites. It can work in conjunction with a lot of specialized add-ins that have been created for it. They make it possible for websites to handle input and output efficiently, as well as process data. If you want to work with JavaScript, W3 Schools is a great bet. Free learning, step by step, and you can practice demonstrations right on the site. And then there's Python, which is not a new language, but it's got a lot of attention in the last few years, and that's because it's easy to learn and can do a lot. Python is one of the languages you might program small machines like Raspberry Pis and Arduinos with. Looking at example programs with sample input and outputs right side by side is a lot of times it's enough to look at that and go, I can tell what that program is doing just by seeing what the input was and what the output is. If you want to learn Python systematically, though, step by step with practice examples right on the website, again, go to W3 Schools. It's free learning, it's very clear lessons. That's where I studied Python. It's a good bet you've heard of the programming languages called C and C++. These are powerful and popular languages. A lot gets done by those. But they're not the quickest to learn. They're a little bit more complex, maybe a little bit more abstract. They could be your first programming language, but if you're looking to ease into programming, or if you're going, I'm going to try this and see if I like it, I probably wouldn't start there. You probably stand a better chance with Python or with Visual Basic for applications. And speaking of easing into things, would you like to learn the basics of programming logic without learning a programming language? It is possible with Scratch. Scratch is a platform created by MIT that allows you to piece together a program literally. English language statements like take so many steps appear on a puzzle piece that you can fit with other puzzle pieces to form a whole program. So you might take this piece where it says take so many steps. There's a little drop down. You can pick the quantity, say take 3 steps. You might then take another puzzle piece and graphically fit it together on screen by sliding the 2 pieces next to each other so that the whole program would read, take 3 steps, turn 90 degrees. You can put all kinds of pieces together that already have logic on them, and then when you get a little bit more experience, you can build your own so that you can customize the language. There are all kinds of example programs out there, and there's a whole set of tutorials. I will tell you that when you get out and look at Scratch, you're going to say, oh, this looks like it was designed for kids, partly because the instructions you're writing are for a little graphic on the screen, and the default graphic is a little cat that carries out your actions. The little characters that are offered to you are called sprites, and yes, the sprites do feel like they were designed for children. But hey, what do you care if you're learning what you want to learn, right? All right, hopefully I have convinced you that there are some good avenues for learning programming, there are some good reasons to learn programming, and you're perfectly capable of doing it. Check the show notes for resources, check the website for this transcript, and we will see you again next season. Don't forget to tell your friends about us. Don't forget to contact us through the feedback form, and we will see you real soon in the next season. That's all we have for today. This is Dean saying thanks for listening, and we hope to have you back with us next time on Teachers to Tech.